Hey everybody, it's Bus Jockey MJE Diagnostics. I thought I would show something to everyone real quick. I was working on a 2017 New Flyer with a B67 Cummins engine in it, and it had codes for the DEF quality sensor, abnormal update rate, the temperature not correct, abnormal update rate, and the level. And it also had a code for the intake NOx sensor for abnormal update rate. So I've got two of those codes coding, and I bet you're asking yourself, well, which route do you go, which one it is? So the first thing I did was I hooked up the Autel here, and I graphed some data. So I looked at couple different things like mass airflow rate, or air mass flow rate, sorry. And then I looked at my engine intake NOx, and then I also looked at the DEF quality PIDs as well. So as you see here at the very end of the test drive, down on my recording here with the Autel commercial vehicle tool, I noticed that here my intake NOx was still holding. I had 276.3 parts per million. The NOx 1 reading was stable, but when I scrolled down here to the diesel exhaust fluid concentration PIDs and property PIDs and tank volume, they all went blank. Okay? And then when I scrolled ahead one more time, let's see, let me go another frame. The next frame I went forward, my intake NOx PID, it went blank. And then also my DEF quality PIDs went blank. So for fluid concentration, property, tank volume, tank temperature, all that stuff. So at that point, I then used my Escope to diagnose the issue. So I went to the quality sensor with the scope, and I checked it, the can high and can low, and then the current. And what it ended up being was the quality sensor was intermittently shorting to ground. Let me turn this on and I'll show everyone real quick. And here we go. So I'm using a microamp current clamp. The blue trace here is the current, yellow is the voltage, red is can high, and then the green is the intake NOx sensor current. I was looking at that as well because I was wanting to see if something was going on with the intake NOx sensor current. A lot of the time what you can do is you can check the current of components and look at it with the can, and it'll help you figure out what's going on with components, if you got a faulty component, if you got an open, short, and so forth. Okay, but if we zoom in here, when this happens, the current goes excessive through the roof, and then the yellow trace for the voltage to the quality sensor, I was at, it went down to like, I'm at 22 volts here, then it goes down some more, and then I'm at like about 6 volts. Looks like 6. Let's drag that down. So yeah, so 6 volts at the top right here. And then also when that happened, if you also look at can high, I was able just to go off of can high for this. But if you look at can high, right here, I'm at a 2.5 volt bias, pretty close to it. But then when it turns on, when I turn the ignition switch on in the back, voltage is applied to the sensor, but then we have an overcurrent, and then it brings down this bias here of the CAN bus. So that proves that this quality sensor is faulty. And also the current, here, move that out of the way. Yeah, the current, it went up to 222 milliamps. So that's way too much current for this quality sensor. So anyway, I thought I'd show that to everyone just to give you an idea of what I do. And give me a shout, let me know if you'd like some actual scope training on HD and other training pertaining to it, giving specifications, known good, known bad waveforms. Anybody who buys the Escope kit from me, they get all that good information and that knowledge from me. So not only do you get a nice piece of equipment here, but you're going to get the training on HD as well from me. So I give online support for free. If you want me to come to your property, then of course I have to charge a nominal fee. But if anyone's interested, let me know. And I look forward to seeing anyone who's interested. So anyway, have a good evening. Thank you. Goodbye.